Good morning, everyone, and welcome back to Physical Science Online. This is Ms. Vukovic here for our fourth week of online learning, and this week we are talking about properties of matter. For this week, your target is to be able to distinguish between physical and chemical properties given a scenario or description. All right, so let's get started with physical properties. Physical properties are characteristics of matter at any level that describe the matter as is. A physical property can be applied to matter at the atomic level, a compound level, or even a mixture. So it doesn't matter how much because it's inherent to the actual matter itself. So some things that we can classify as physical properties are listed below. The ones that we should practice are the first 5. So state of matter, we all know, is solid, liquid, gas. But as freshmen, we want to be able to talk about how are the actual atoms arranged and acting in that solid, liquid, gas state. Boiling and melting point are the temperatures at which a substance is going to change its phase. So it's going to go from one state of matter to another state of matter. Solubility. Solubility can be kind of tricky, but the main question is, will it dissolve? Most of the times to test solubility, we put a substance in water because water can pretty much dissolve most things. Conductivity we've talked about a lot before, and conductivity is just this idea that electrons can flow really easily throughout the material or the substance, so it can produce electricity. Malleable and ductile are words that describe the ability for your substance to be made into a certain shape. We've talked about before that metals are very malleable, and that's why we have a lot of different metal shapes in our houses. Think of like a kitchen faucet. We can include physical properties to be things like shape, color, temperature, even measurable properties like mass, density, volume. Those are all physical properties because they describe the matter as it exists. So if you just looked at it and you were able to use your 5 senses to observe, you would be able to describe a physical property. This slide shows some examples of physical properties. On the right, you'll find that physical properties are listed, and so you have color, shape, mass, volume, boiling point, states of matter, ductility, and malleability, and some additional descriptions of those words. On the left side of the screen, you'll find that you have states of matter. What I want you guys to pay attention to and try to get a grip on is this idea that each state of matter has its atoms or particles arranged differently. So in a gas, the atoms are really spread apart, whereas in a solid, you have your atoms really condensed. This arrangement of particles in solid, liquid, and gas are what go on to dictate whether you're going to have materials being highly conductive or ductile. It can also talk about volume. So all of these particle arrangements of solid, liquid, and gas actually lead way to these other physical properties as well. For instance, one example is because solids have their particles so close together, that allows for electrons to flow between the particles really closely. So a lot of times solids are really conductive, especially metal solids. So that's just one example. Our second target for today is to be able to describe or define whether something's a chemical property. And so chemical properties are different and a lot of times challenging because people think it's the actual action, whereas chemical properties are really only describing the ability. So, for instance, before we even get through all of this, we can say that someone has the ability to do a pull-up, but that's different than somebody actually doing the physical act of a pull-up. Right now, we're just talking for chemical properties about the ability. So, can it react? Can it create flames and fire? So this is just asking the question, can some matter react or form a new substance? Okay, so can it? Chemical properties are characteristics of matter at any level. So again, at the atomic level, all the way up to mixtures at any level, and it describes the way a chemical or a substance will react. The two that we pay attention to are flammability and reactivity. Flammability is just this idea that if it's present in enough oxygen, so if this material exists with enough oxygen, can it light on fire? We all know that there are some materials that cannot, and then there are some that aren't. So is it flammable? Yes or no? We can also talk about reactivity. And this is the idea that this substance is going to combine with another substance and react. So the question for reactivity is, will this matter or substance react with something else to form a new substance? If you think back to when we talked about the periodic table, we said elements in the first group were highly reactive. We even watched a video that showed some kids throwing a big chunk of sodium into water, and we found that it exploded and it made something kind of like a bomb. So that's what we're looking at, is will this react? Will there be some sort of sign that there was a reaction? And it's not like the actual process of it reacting, it's just, will it? Can it? And so it's, again, more of a yes or no question. So this graphic gives you two additional chemical properties, and it's the ability for something to rust and the ability for something to tarnish. If you think about like a bike, if you leave your bike out in the rain for a long period of time, you're going to find that that metal is reacting with the water and the air around it, and it starts to rust. Rust is a byproduct of a chemical reaction. As well as when silver tarnishes, that's also a reaction. So chemical properties, we will elaborate on and start talking about chemical changes next week, but you need to know that chemical properties are all about the ability to change. So can it change into a new substance? And that can happen through fire, it can happen through a chemical reaction, and those chemical reactions can be like rust or if something tarnishes. So there are two activities for you to do this week, and the first one is a Google form that you'll find on Classroom. On that form, you'll find that there are 5 different scenarios and descriptions of properties, and it's your, oh, my cat just showed up. It's your job to identify whether those are physical properties or chemical properties. So first thing is Google form. The second thing is that you can explore these physical and chemical properties at home. And one really neat way to explore physical properties is by doing something called a heating curve. So we talked about boiling point and melting point as physical properties, and you can actually explore the boiling and melting point of water at your own house. So if you are going to do this option, which is totally optional, you have to make sure you have either parental supervision or parental permission, because I do not want you at the stove unsupervised. But what you will need are ice cubes, a thermometer, a pot, and then the stove. And if you don't have those, especially the thermometer, you probably can't do this. So a thermometer, try not to use your parents' like body thermometer. Try to look for like a kitchen thermometer. Okay. What you would do. First step, you want to put the ice cubes in a pot on the stove and record initial temperature. I drew out a example data table, and you would just record the temperature. So at time 0, the temperature is blank degrees Fahrenheit, or you could do Celsius. And that would be your ice cube. You'll probably want to do multiple ice cubes so that it covers the bottom of the pot. Then you will turn on the stove to medium heat. Observe the ice cube melting. So you should be able to observe that ice cubes are going to melt. Between step 1 and step 4, you want to make sure that you're recording the temperature every 2 minutes. Try not to have the thermometer sitting on the bottom of the pot. Instead, try to make sure it's touching some sort of ice cubes. So you're recording the temperature every 2 minutes. You're going to observe the water boiling at some point. Try not to let it bubble too much. Safety first. You don't want to hurt yourself when you're going to take the temperature. So if it starts to bubble uncontrollably, you can always turn the temperature of the stove down to like a low heat. So every 2 minutes you're recording, you're going to watch that water is going to start to boil. And then you're going to record the final temperature when there's like noticeable evaporation. So you should be able to see water vapors coming out of the pot when it starts to boil. Once you get to that point, you can maybe do 1 more or 2 more temperature recordings, and you should be good. At the end, you're going to make a line graph of temperature versus time. So you'll have melted your ice cube and then watched it evaporate. You'll have recorded the temperature every 2 minutes. So 2, 4, I mean to do that, 6, 8. And you're going to record the temperature, and then you're going to make that graph. Remember, temperature should go on the y-axis, and time should go on the x-axis. You don't have to turn this in. You can take a picture of yourself and email it to me if you want. You can write a little reflection on Google Classroom, but you don't have to turn this in as extra points, extra credit. It's just an opportunity for you to do something scientific in this time of being home. So if you have any questions, reach out to me. In addition to all of those things this week, so in addition to all of the things that you have to do for me, I'm also going to ask that you fill out this feedback form. I just want to know how you guys are doing. How is online learning going? Am I doing an okay job? Totally be honest. I do not mind. So fill out the teacher feedback form. You'll find it on Classroom. And lastly, if you guys are looking for like some more engagement, or you're just kind of looking for a way to feel connection, lots of days I am posting on my Instagram, and sometimes I'll give you like activity suggestions, or I'll ask a question on my stories that you can reply to. So if you're feeling like lonely, always feel free to follow that and send me messages, because I will most likely answer or repost them, and it's just a fun thing to do. All right, so I miss you guys. Hope you're staying healthy again, and as always, please reach out with any email questions. I am going to try to keep track of your grades for this week, so if you notice that you have zeros and you're not supposed to, give me a email and I will get that fixed for you. All right, have a great week. Bye, everyone.